So, particular question where you have to apply the skills of homogeneous technique. Now, for example, the first one is you have equation has been given as the derivative is x squared plus 3xy plus y squared over x squared, and it has been given that f of 1 equals to 1. Now, the first question comes with that sometimes they mention the word homogeneous and sometimes they don't mention. So you got to look at like the combined degrees of each of the term. Like here, if you look at the degrees 2, here if you look at the degrees, combined degrees 2, and here if you look at the combined, the degrees 2 and degrees 2. So if degree of numerator and degree of denominator and all the terms have own the same degree, then we call the equation to be homogeneous equation. Now such equations can easily be transformed to f of y upon x. So f of y upon x, what do we mean? Like dy by dx can be written as f of y upon x. Now, when I say that, I simply mean that if I divide it and isolate each term, x squared upon x squared plus 3xy over x squared plus y squared upon x squared. So this gets cancelled, one of the x get cancelled. So you can see that this is y upon x plus y upon x the whole square. So you can see that I could write in the derivative. Whenever the expression is homogeneous, the derivative can be written as a function of y over x. This is a function f of y over x. So this is basically referred as what you can say is the homogeneous equation. Now, when you're solving this, as we had discussed, the strategy is that you take y equals to vx. Now here, v is not a constant. V is a variable itself. So actually, sometimes you get the substitution as v is y upon x and vice versa. So any one of these is actually considered as the right substitution. They're the same thing. Now, the first step, what you got to do is, since you're substituting for v as a variable, you're going to find out an equivalent expression for dy by dx. So dy by dx, when you look at it, is v times 1 plus x times dv by dx. So dy by dx here, it's going to become OV plus x dv by dx. Now this, I would recommend that if you can remember it, like for homogeneous equation, this can definitely save some time. So in place of dy by dx, I can substitute basically v plus x dv by dx. So this can be put basically out here. I can take it and put it in place of this. So let's see what we get. So it is v plus x dv by dx equals to x squared plus 3x, and instead of y, I'll put now vx. So vx plus v squared x squared upon x squared. So this becomes, you can take x squared common clearly, and this will become 1 plus 3v plus v squared over x squared. So this get cancelled. So the objective of the substitution is actually to get rid of the x term basically. Now bring in this v to the other side, and as a result of this, what we get is x dv by dx equals to 1 plus 2v plus v squared minus v. So this basically becomes v squared plus, this is actually 3v here, so this is 3, so this is 3. So v squared plus 2v plus 1. So now we got until here. After this step is, so you got x dv by dx is basically v squared plus 2v plus 1. Now we need to solve this equation. So isolate each term. So dv upon, separate the variables, 2v plus 1 equals to dx upon x. So now if I integrate both sides, this part is nothing but dv upon v plus 1 the whole squared, if you see. And this, of course, the integration is ln x plus c. And this one integration you can do is v plus 1 to the power -2, because if you take up the power, and so -2 plus 1 upon -2 plus 1 is, which is -1, and divide by coefficient of v, which is 1. So equals to ln x plus c. Now after this step, we got 1 over -1 over v plus 1 equals to ln x plus c. Now, instead of v, you can put as, if you wanted to make v the subject, firstly, you have to, sometimes they say that write down y as f of x, means it has to be explicit function. So -1 upon v is nothing but y upon x plus 1 equals to ln x plus c. Now, since they have given in the question is that if you look at when x is 1, y is 1. So when x is 1, y is 1. So plug x is 1 and y is 1. So it becomes -1 upon 1 plus 1 equals to ln 1 plus c. This is 0. This is -1 upon 2 plus c. I mean equals to c. So c is basically -1/2. Now I'm going to put that c as -1/2 here, and then I'm going to make y the subject. So -1 upon y upon x plus 1 equals to ln x minus half. Transfer the sides. So what we get is y plus x plus 1 equals to -1 upon ln x minus half. Then you bring 1 to the other side. So you get y equals to this answer, basically this answer as it is, -1, and then whole thing you multiply it by x. So the answer is -1 upon ln x minus half here, times x, and there's -1. So this is like the basic skill that you need for homogeneous technique.